I said everything gonna be alright. I said everything gonna be alright.
Everything's going to be all right. Good day wherever you're listening from, and welcome to Indoor Air Quality Radio, IAQ Radio. It's Friday, November 11th, 2016. This week is episode 437. My name is Radio Joe Hughes. I am in the studio, Studio D, that is, in Central City, Pennsylvania. At the controls is our engineer, John. You gotta have faith. And joining me back from Studio C in McKees Rocks is my co-host, the Z-Man, Cliff Zlotnick.
Good afternoon, Joe. Hi, John.
We got you.
Hello, everybody.
Good to have you back there, Cliff. And this week we welcome Linda Wigington of Linda Wigington Associates. We're going to talk a little bit about the Nexus of energy and indoor air quality and the Reducing Outdoor Contaminants in Indoor Spaces program that she's been working on here most recently. Before we do, we've got to stop and thank our marquee sponsors.
John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
Clean Facts, the number one information source for cleaning and restoration professionals. Check them out at cleanfactswithanx.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products.
And last but not least, please visit the IAQ Training Institute website for the training you trust at IAQtraining.com. Let's turn it over to the Z-Man for today's IAQ Radio trivia question.
Thanks, Joe. Win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer the IAQ Radio trivia question each week. Submitting your answer is very easy. Either email it to czlotnick@cs.com, or if you're listening to the show live, you can text in the answer with your computer. Congratulations to Doug Conan, Aerotech Environmental in Dayton, Ohio, for that lightning-fast answer to last week's IQ Radio trivia question. The IQ Radio trivia question for Friday, November 11, 2016, has been sponsored by Ideas, the solution chemistry company, creating unique solutions to odor removal, surface cleaning, and decontamination problems. It's Veterans Day today, and we extend our thank you to past, current, and future members of our military service. Now for today's IQ Radio trivia question. Which of the 50 American states consumes the most power per household? Back to you, Joe.
Okay, we've got Linda Wigington, and through her company, Linda Wigington Associates, they are involved in initiatives to evaluate and redefine the process, scope, and value of residential energy reductions. She is currently demonstrating the feasibility of achieving deep reductions in existing dwellings throughout North America on the 1,000 Home Challenge. Some listeners may know her better as being the founder and being associated with the Affordable Comfort Conference from its inception in 1986. She's also been involved in numerous other programs over the years, and most recently, she's been working with the ROCIS program, which is the, and I lost the name of that one, but anyway, Reducing Outdoor Contaminants in Indoor Air since its inception in June of 2014, and the Low-Cost Monitoring Project, which began in 2015. In the past, she's also been an advisor for the Habitat for Humanity International Green Team, and currently is on the editorial board of Home Energy Magazine. She also received the American Council for an Energy Efficient Economy's 2002 Champion of Energy Efficiency Award. We've got a little music for Linda.
Every home needs heat, every home needs light to keep us working and playing every day and night. But you can turn down the heat, yeah, you can turn off that light. And when it comes to tomorrow, it'll be alright.
That's great.
Welcome, Linda. Great to have you.
Good to be here.
All right, I was muted there for a moment, but I am back. Hey, let's talk a little bit about first how you got involved in energy efficiency and building science. What led to your interest in those areas?
Well, as a teenager, I was a little bit of a rabble rouser. I was, I guess, an environmentalist, and actually it was my mom that continually said, it's more important to be for something than to be against things. Make sure you're for something. And then through college, I was involved in some environmental issues, and it became real clear that just being opposed to stuff wasn't effective. That I mean, in that case, it was nuclear power. There was projected to be 1,000 nuclear power plants built in the next 20 years or whatever, and it didn't matter whether or not they were safe or whether or not it was the direction to go. Everything seemed to come back to, yeah, but we need the power. So it really occurred to me that the real root of so many of our environmental problems are energy efficiency, or our assumptions regarding how much energy we need and how much we need in terms of resources. So I thought it really made sense to commit my life to the root of the problem, which is an exploration of what we need to live well, how can we truly function as just as with incredible health and wealth, but with a minimal impact on the environment.
You know, I'm curious then, once you made that decision, how did you figure out where to go to get this information you were trying to gather? I mean, energy efficiency, I don't know if it was always thought of as use less as opposed to find better ways to generate it. How did you get started?
Well, I mostly from the standpoint of thinking about my own life and impact. So that's like all of us. We live in places. We live in homes. So it was a matter of exploring my own home and my own actions and how what impact I had. And I was able to get into a graduate program at WVU that was program for the study of technology, and there was a real interest in appropriate technology at that point, and we actually did got some programs funded to do energy education for homeowners, and had a demonstration house that was funded to demonstrate energy efficiency and alternatives. So the focus of my graduate work was residential energy efficiency and alternatives and community energy education. So I zeroed in on that, took some engineering courses, but I was not just interested in the technical stuff. I do think that the issue of the intersection of what's thought of as energy conservation, or choosing to use less versus using what you do use more efficiently, is where there's the greatest impact. And it's not just a matter of efficiency alone. I think they really go hand in hand, and in way too many cases we don't really explore what our options are. And as long as we don't explore what our options are, we tend to come up with the assumption that we just need to continue to use more energy, regardless of the environmental impact. And I think that's very false, huge false assumption, a myth that is the cause of an awful lot of the problems we're facing right now.
Well, you not only talk the talk, but as I understand it, you walk the walk, and that you do some things in your own home. What have you done after exploring this in your own home to help reduce your carbon footprint?
Well, I have a house that was built in the 40s, and when I bought it, I insulated it well, air sealed, put in a mechanical ventilation system. Did the things that made, added more attic insulation. Did things that immediately made sense. Since then, I've switched over and added 2 ductless heat pumps, a heat pump water heater, changed all the lighting to LEDs, monitor my base load, my electric use, added movable window insulation, what's called window quilts, and also just manually inserted, because I kept most, I have all but one of my original 1940s double hung single pane windows. But basically I've gotten to the point where I added a small PV array, photovoltaics, for generating electricity. It was generated about 2,100 kilowatt hours, and I was able to be net zero. So that was cutting it really close. So I mean, it was like putting a dehumidifier on a 1-hour timer, which didn't quite keep my basement as dry as it should be. So I added more PV, and I'm pretty much within the net zero energy with about 4,000 kilowatt hours. I'm total, all electric home. So to only be using 3,000 to 4,000 kilowatt hours is pretty low energy use. And probably the biggest share of my energy use is for dehumidifiers, air cleaners, and monitors. That probably is more than my ductless heat pump energy use. But part of what I do is definitely lifestyle. I learned that sort of by accident that I could be comfortable at a lower temperature setting. So I've been experimenting, and since then my temperature setting has gone up a little bit over what it had a few years ago. But I was just curious to find out, well, what does it mean to be comfortable, and how much energy can you save by choosing to achieve comfort in a different way? So I call that creative comfort. So I, had my thermostat setting during some period of time around 55 to 60. Since then, it's crept up more to 60 to 65. But I'm perfectly comfortable at that temperature setting, and that's partly why I can have the energy use I have.
Interesting. Cliff, let me turn it over to you for a minute.
Hey, Linda, thank you for joining us. I've got a question. Do you live alone?
Yep, and that's a major factor. When you live with somebody else, there's a dynamic that can really limit your options. and certainly getting along with who you're living with can be far more important than one's curiosity and exploring boundaries of thermal comfort. So, great question.
Yeah,
I also do not cook as much as most people do. So
the reason I asked is my wife and I have been married. We're going on 35 years or whatever, and she likes it really cold, and I mean like colder than normal, and it's tough on me. But that was why I asked the question.
All right.
They call that dueling thermostats, and it's one way where, creating a comfort zone in a house so that one person can be comfortable at their own thermostat setting and someone else can be comfortable at a different thermostat setting makes a lot of sense.
Right.
Let me ask this. I mean, I believe, that in your bio, it talks about your experience with the Passive House program over, I guess, in Europe, and now it's starting to grow here in the United States, and I know you've been involved with the U.S. group as well, but I guess most importantly, how did your experience with Passive House shape your views today on what can be achieved?
Great question. And that sort of leads back to with my experience with the Affordable Comfort Conference, which is, I was basically program coordinator for, basically developed the agenda for our conferences from 1986 to 2010 or so. I was very much in the position of understanding what's possible and practical in terms of energy efficiency in existing homes. And I was well aware that most evaluations show that programs don't save as much energy as we predict, and a really good program, exceptional program, might save 25 to 30%, like natural gas. If you have uninsulated homes and you insulate them well and replace some furnaces, and but that's a really good savings. So the notion that you could easily save 50 to 70, 80% savings is just considered, not valid across a group of homes. It's truly an exception. Well, a friend of mine was involved was in Europe for a while and had attended some Passive House stuff, and Passive House is basically an initiative. They give credit to very, very good work that was done in the U.S. and Canada that actually caused them to explore what could be done in terms of super insulation. And it's not passive solar. It's Passive House basically means you make a house incredibly energy efficient from the standpoint of insulation and airtightness, and then you've got a lot more flexibility in how you actually heat it. You don't typically need a conventional heating system. So in talking to a friend, I just always considered that, sort of out there, not practical, not reasonable, but well aware of everything that's going on in terms of climate change and the need to drastically reduce our energy use, and realizing that everything that I was doing within affordable comfort and advocating only gets you, 20-30% of the way. It's like, how do we truly change existing housing stock so that we anywhere approach carbon neutrality? Is like there's this huge gap. And what I found out was Passive House was actually demonstrating that it was possible to drastically change the way buildings perform. And it was really intriguing to find that out. So it's part of what I didn't say about my lifestyle is that I just constantly want to sort of learn from what I'm doing and also find out for sure whether or not something works. Sort of prove it to myself. And to me, it was a major change of perspective to realize that the things that I thought were not possible were not only possible but achievable. And in talking to my friend John Krieger, he was talking about how, particularly in masonry buildings, a lot of apartments, a lot of big buildings in Germany and Austria, that they were developing systems to insulate on the outside, and systems to make it much easier to do so. So these chunks of insulation were like blocks that would fit together and corner pieces, and so it was like Tinker Toys kind of all coming together as a system. So they were actually moving from something being at the experimental stage to making it so that, no, you can actually do this routinely. And obviously, if you've got uninsulated masonry buildings in a cold climate, you can have a huge impact on the performance of a building. So they also called for extreme levels of airtightness that I thought were not at all possible. And what's been interesting to see is that, yes, indeed, I don't know much of your listening audience is used to doing blower door tests, but certainly within the building performance, home performance folks, CFM 50 is the measure of airtightness in a typical house, and it's the number of cubic feet per minute at 50 pascals, which is what you measure with a blower door. And typically, within existing homes and average homes, you figure if you're getting it below 1 CFM 50 per square foot, you're getting pretty good. Above that's not as good. I mean, that's a really rough rule of thumb. But Passive House was calling for something that was 10 times tighter than that. So I remember the first night that I actually got the data on what it took to meet the Passive House standard, and I plugged in my home's data, and I thought, wow. I mean, my house is pretty tight. It's like 950 CFM 50, and I would have had to get it down to 110. Wow. And I'd done the air sealing on my house, and I knew what my energy use was. At that point I was pretty low. It was only like a couple hundred gallons of oil, but to meet the energy performance, it would have to have been more like 80 gallons of oil. It was like, holy cow, how would I achieve that in my own home? So it just made me realize that, what would it take to do that? So what was most interesting was then going down the path of exploring and seeing who and what we were learning from different Passive House projects. And definitely it's a whole lot easier to achieve those levels of airtightness in new construction or absolutely major rehab, and I think Passive House has actually taken off fairly well in the U.S. That's probably the most promising market is major rehab of masonry apartment buildings. And it's, a huge opportunity there, particularly in cold climates. They, for the most part, are uninsulated. And the key thing about Passive House is it's very holistic. So it's really looking at, you got to really insulate it well and make it airtight so you don't have moisture going into places where moisture is not supposed to go. But then you're also making sure you've got mechanical ventilation that's distributed, and that's an essential part of it. So it's got a very holistic sense of collection of principles to guide a project. But it's not based on what you actually achieve in a building. It's based on a predicted performance of a building. So yeah, I mean, it's an awful long answer to your question, Joe, but the key thing was it made me aware that it was possible to go far deeper than we thought in terms of energy efficiency, but it also gave me a framework of, well, how else could we get that same level of performance? And in my case, my house achieves, does not meet Passive House standard. It would need far more insulation and have to be far tighter. However, my energy use would be equal to the same as a house that meets the Passive House standard because I've chosen to live differently. And to me, that's the incredible gift, is the idea of just re-examining how we live in order to think about the fact that it's quite possible to drastically reduce our energy use and live well and also have very high, good air quality and good control of humidity and do all those things, but do it at a fraction of the environmental impact that most homes have.
I think that's a good foundation on which to build for the rest of the show. I mean, but before I jump over to the next question, I'm curious. Do you know how much Passive House has caught on in like Germany and Europe? Is it 1%, 5% of new construction? Do you have any idea where they are with that?
No, I haven't followed it closely recently. I was involved early on, quite a while ago, 10 years ago. What I do know is there's some communities and cities that were calling for it to be the standard for new construction or major retrofit. And one thing that's interesting is actually net zero energy has caught on, and in some cases with bigger buildings, if you're net zero energy, you might actually go beyond Passive House. So even though Passive House is sort of seen as the extreme level of energy efficiency, it's actually, because it's based on energy use per square foot, it actually is not as high a standard as might be justifiable if you're truly trying to achieve net zero energy buildings or communities.
And I'm curious, what about the biggest kind of objection I hear is the cost of the insulation and the tightness and the blower door testing and all that. I have a little contracting company here. I can imagine me trying to tell some of the locals up here in Somerset, or get them to do this. How do we get people beyond that? First of all, I guess, is it that big of an expense? And secondly, even if it is, what's the payoff?
Now, that's a really good question. I think it can be incredibly expensive if you're just learning, if you're on a learning curve, or if your systems don't work, or if you don't have folks that are committed to the process and you're trying to, push people to do something they don't believe is practical. But there have been cases. There have been some neat developers and contractors, some of single-family housing stock, some folks in the Northwest. There's a guy in Massachusetts that, I'm not sure in the Massachusetts guy, I don't think his homes are necessarily Passive House, but they're net zero energy without a huge photovoltaic array. And they basically are building these homes at basically market rates because they've got really good systems. They've really looked at the optimization of everything within the house, so they're really looking at trade-offs and how to make the system work. So they're not just trying to add on to the way that they used to do it. They're rethinking how you do stuff. So to make a house really, really tight, for example, new construction, you basically make the frame airtight, and then you'd put interior partitions and stuff. You wouldn't go in and do all your interior framing and partitions and then try to air seal from the inside. You might have an entire skin on the outside that would totally enclose the building, and you minimize the operable holes. I mean, and you really rethink how many windows you have. You make sure the windows you have are strategic and are going to do the right job. So the idea of not compromising good lighting, not compromising ventilation, but not just putting windows in for the sake of windows. You think about, okay, does this window need to operate? So you could end up with less glazing area, but better lighting, less glare, greater comfort, but save on windows and yet spend more to get the high performance, the windows that have an R value of 7, 8, whatever, rather than an R value of 3. So there are neat trade-offs that you can do when you really think through the system. Now, I do think one of the real good criticisms of super insulation is how long does it take to pay back for the energy invested in the materials you're using. Mm-hmm. And that's something that the Passive House folks have really tended to say, don't use all this foam. Use materials that are less energy intensive. And because of that issue, if it's going to take you 40 years to pay back the energy investment of foam, that doesn't make sense. But definitely I think there are good systems using appropriate materials where building new in either single-family, multifamily, fourplex, commercial buildings, where you could go in and achieve a high level of performance that's substantially better than what we've got now, and verified performance, not necessarily Passive House, but it takes time to develop the systems and tweak and to get everything right, and to assume that you're going to get it right the first time, to assume that you're not going to have a learning curve would be a big mistake. So the role of feedback and verification is absolutely critical. And we've seen houses that are built to meet the Passive House standard, but don't meet the energy performance expected because they weren't anticipating how much higher the hot water use would be, or how much higher the electric use would be for radon mitigation or dehumidification, or all the plug loads we have, all the phantom loads we've got. So there's a lot to be verified and learned from. I think what we need is a path of continual improvement and learning, and every project should be seen as an opportunity to learn, to tweak, and make a system even better. But definitely the cost issue, what you hear in some cases, if you're not taking into consideration just the cost of designing the house but building, maybe a 5 to 10% improvement or increase over the cost of conventional. Mm-hmm. But not, we're not talking about 300%. We're talking about small increases, and depending on the systems used, I think it can be very, very reasonable and justifiable.
Okay. And before we break for halftime, I want to get started on the main topic for the second half, and that is the ROCIS program here, the Reducing Outdoor Contaminants in Indoor. I forgot the S, but Spaces. Thank you. Spaces. All right. Tell us a little bit about how that. How did that get started, the ROCIS? And that is, am I pronouncing that right? ROCIS, ROCIS. Yes,
ROCIS. We're not ROCIS. We're ROCIS. So ROCIS is an initiative. It was it's funded by the Heinz Endowments in Pittsburgh. And it's not an organization. It's an initiative. I'm the leader, cat herder, whatever. So it consists of having several folks working under contract, and primarily the mission is to reduce the impact of exterior environmental pollution in southwestern Pennsylvania in order to improve healthy and energy-efficient indoor environments. And that's where we live, work, and learn, so basically buildings. And the main way of doing that was to work with, establish, and support a stakeholder group, and to constantly broaden and deepen that stakeholder group of folks who are involved and have in any way in their, primarily as professionals, but in some cases as advocates, folks that are involved in sustainable housing, affordable housing, healthy housing, all the health-related air quality stuff like asthma, monitoring. I know I'm leaving folks out, but basically home performance. The whole array of professionals who have some touch in that area, to bring folks together, to learn from each other, and to also challenge, to redefine how we think about healthy homes and buildings. So the ROCIS initiative initially began developing a couple white papers, having meetings, bringing folks together, and really exploring the issue of the impact of outdoor contaminants, because for the most part, the common perception across the folks that I'm describing, the organizations and individuals, whether they be nonprofits or private sector businesses or academic or consultants, the common perception within building industry is that if you want a healthy house, you need to take care of the sources of contaminants from materials and from occupants in the house, and you've got to have good ventilation, and you've got to bring in outside air to dilute the stuff that's inside. And you basically, that's the key. I mean, that's overly simplistic, as you know, but the whole idea of ROCIS was to raise the question of, but what if you've got stuff that's outside? What if the water coming in when you heat it generates pollutants when you take a shower? What if the outside air you're bringing in is really dirty? What if you've got soil gases, including radon? So that's been our focus, is that how do we change the paradigm of the folks who are working in this larger area, and support organizations in developing initiatives in order to address and minimize the impacts we find in southwestern Pennsylvania, which there's lots of opportunity for improvement, because we do have some of the worst air quality in the U.S. According to the recent a State of the Air report by the American Lung Association, Pittsburgh is either the 10th or 11th in the annual and in the 24-hour particulate matter, 2.5. So 10th out of all of the communities in the United States that were tested, and most of the ones that are worse are in Southern California. So we've got lots of opportunity. We've been getting better. We used to be worse, but we're still the impact of the environment is huge here.
I can imagine what it was 40 years ago when I was growing up in the area. I mean, or even 50 when all the steel mills were cooking, and oh my goodness, we had to be in the top 5 then, But let's do this, Linda. We're going to stop. Thank our sponsors. We'll be back in 90 seconds, folks. We'll be back for the second half with Linda Wigington. We're going to talk a little more about the ROCIS program, and then we're going to get into a little bit on the low-cost monitoring component of that, because I think there's some very interesting information in there. So we'll be right back with Linda Wigington. And thanks to our association sponsors, the Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org.
The Restoration and Specialty Cleaners Association, who have been serving the needs of and advocating for their members for over 30 years. Remember, Triska is your link to industry training, certification, standards, and events. Their website is trsca.org. Thanks to our advertisers.
Gray Wolf Sensing Solutions, who use advanced sensor technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Visit them at legends-enviro.com.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
And, of course, our marquee sponsors. John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
Clean Facts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfactswithanx.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products.
All right, we're back for the second half of our interview with Linda Wigington. We ended talking about the Reducing Outdoor Contaminants in Indoor Spaces initiative, and now we're going to focus a little more on the low-cost monitoring project portion of ROCIS. Linda, can you tell listeners a little bit about how that started out and what the goal is?
Sure. The low-cost monitoring project came about because we had a lot of interest among our network of stakeholders in adapting and incorporating monitoring, low-cost monitors into different programs and initiatives they were doing, and yet the products were just beginning to come on the market. No one really had experience, and it seemed like we could really support our broader network by establishing some experience with that and giving folks the opportunity to use them. So we basically wanted to understand how they could be used in order to empower occupants. Do they empower or do they overwhelm? We wanted to understand what the challenges were just in using monitoring equipment. How user-friendly is it? What kind of information does it provide? What's the issues regarding reliability, durability? We wanted to collect baseline data. We really didn't have baseline data on what to expect. Like what are normal numbers that you'd get doing different things, particularly with a focus on particles. So what's typical, and then what's the variation, what's possible. And then we also wanted to explore the impact of behavioral and technical interventions. So those were the three primary objectives, and what we decided to do was buy a bunch of equipment, create some kits, and basically use a cohort model where we invited stakeholders, initially stakeholders, and then stakeholders, neighbors, and other folks who expressed interest, anyone who heard about it, to participate in a 3-week cohort. So basically people come to a meeting, they get a bag of monitors, and they go home and use them, or go to their workplace and use them, and then we have 3 meetings over the course of the 3 weeks, and we collect data, but we're also really interested not just in the data, but really interested in the people's experience and supporting them learning from that experience.
What have been some of the key takeaways, the big aha moments for you in this when people come back and report? What kind of things are they telling you?
Well, our primary focus has been on particles, so that's why we use half the equipment we provide. We provide 2 specs and 3 dialas. But we did want to make sure that in looking at particles and air pollution and looking at the impact of outdoor versus indoor, we also were understanding indoor sources. So we also included a low-level CO monitor and CO2 monitor, as well as 2 radon monitors. And the first thing that came up really quickly was, wow, there's a bunch of radon out there. And in Allegheny County, the statistics said that 40% of the homes are over 4.1, whatever the EPA standard, and that's what we found in the first cohorts. And yet we had a group, because we were relying on our stakeholder network. These were folks that were typically involved in energy efficiency, energy advocacy, sustainability, healthy homes. These are folks that were already pretty knowledgeable, so certainly 20-30% of the folks involved already had radon mitigation systems. But even so, we found 40% homes that were high, some were very high. So that was the surprise. In fact, we started off with just one radon monitor, which we put in basements, and we doubled that quickly so that people would see that the radon in their living space was usually, at least during the winter, was not quite as bad usually as that in the basement. It varied, but so the radon levels were interesting, and we definitely have seen that the radon levels have been higher in the newer homes. Couple of our folks have homes that had a passive system, but they hadn't followed up to check. And when they checked, they found elevated radon, so they converted their passive system to an active system. But some of those homes were in the higher levels, like over 15, which whereas there were other houses that we had a interesting range. So that was one thing that we weren't expecting. In terms of the particle and the sources, there's a hard question just to answer in general. I suggest we back up to just say...
Yeah, let's back up on two things. First, you talked about the radon a little, and before we go too far, I know you and I discussed that we want to make sure listeners are aware that, you're giving us some generalizations. These aren't necessarily, hard data at this point. Is that accurate to say?
Absolutely. I mean, I guess hard data, it would be data. We're taking measurements, but in terms of extrapolating from that data or analyzing that data, this is not meant to be a research project, a peer-reviewed scientific research project. It's much more meant to be an exploration, because if we strictly wanted unbiased data on houses and comparing indoor and outdoor levels, we wouldn't be using meters that give people feedback and encourage them to learn and play. Because obviously as people do things differently, they're affecting their readings. So we've got this interesting balance between the exploration and experience side and the data side. But we've got a lot of data. We got over 7, 10, whatever million data points of Dilos data to date. A lot of data.
Let's talk a little bit about that. So you've got the spec and the Dilos. I am not as familiar. I'm looking at a spec right now on my desk, and we did a show with the folks from CMU on the spec, and that one focuses on the 2.5 micrometer particle range and above. If I recall correctly, the Dilos, as you were telling me before the show, though, that has two sensors, one at 2.5 and above and one below, or is that, maybe you could expand on that a little bit?
Yeah, the Dilos, actually there's different Dilos models. They've been around for quite a while, and some of them measure 2.5 and 10, and in that range, and the one we're using, the Dilos 1700, measures 0.5 and above on the smaller scale, and then 2.5 and above on the what they call the larger scale. To get the true reading, you're supposed to subtract the larger from the smaller. We find that our ratios are very constant between small and large based on the pollution we're looking at. We usually just use the raw numbers as a frame of reference in order to learn. And all of these are looking at counts. They're not looking at anything that you can equate to directly to EPA criteria, pollutants, and air quality is based on a very well-defined measurement of air pollution with equipment that has to meet certain standards, and particles, or PM, particulate matter, is all based on mass, the weight, with filters. So we're using a device that does not do the same thing, but provides very interesting and possibly more useful results in some ways. So we are looking at, with the Dilos, a smaller count than what typically would be viewed with most of the low-cost monitors that are out there. And the spec did have a bunch of additional work done, and they were really trying to tighten and look more closely at what they were measuring, and I know Ela Norbosch had said that when they did more testing, it was definitely within the 2 to 4 micron range was what the spec seemed to be capturing very effectively.
And real quick for listeners too, the spec is about $200. The Dylos, what's the price range on that one?
The Dylos, if you look at Amazon, it's the Dylos 1700 is $495. We have been able to get them in bulk for $300.
And I've got a text question too, and then this kind of fits in now. Linda, a number of libraries provide a kilowatt meters for members to use. Do you maybe see libraries as a resource for checking out the ROCIS equipment?
Well, actually, libraries in Pittsburgh have been a source of spec equipment, and there are some initiatives that are looking at ways that equipment can be loaned out. And what we're trying to do is look at what is a good delivery model for sharing equipment and for people to learn and benefit from it. So that's certainly part of our inquiry over the past year, is understanding what the value of the equipment is. And basically, I think I think the monitoring equipment can be very useful, but I think it also can be sort of misinterpreted. So I'm probably a little more cautious in saying that the highest value I think you get is with sort of the kind of model we have, where we're providing the equipment, but then we're also helping with the interpretation.
Mm-hmm. Mm-hmm. And what areas of activities in the home have people been noticing, lead to that increase in particulate? Although I know you're looking at outside coming in more often than not, but I guess you're also getting information on activities that raise particle levels.
Absolutely, and that's a clear takeaway, is you just can't look at one. And obviously, anyone that's thought much about homes knows that, well, the tighter you make the house, unless you take care of indoor sources, the more you concentrate what you've got. So you might be better off in terms of excluding stuff coming in from outside, but meanwhile you've concentrated the inside stuff. So you cannot win unless you address, and you need to address both indoor and outdoor sources, and you need an approach that does that effectively, and understanding what those sources are and addressing them. So what was your question?
Well, what are the big sources that people weren't,
A big source?
Yeah.
Yeah. Okay, so what we constantly see is that, cooking is always a big aha surprise. And that shows up clearly on the spec and the Dylos, the full range of particle counts. And even when people have hoods and use the hoods, they often see significant spikes from that. The other thing there are a number of things that people see. One is just any activity. So when they're sleeping, they might, wake up and the level's fairly low, and then as soon as you start to move around in the house, degenerate. So oftentimes just any activity in houses with more kids and more people, as soon as the kids come home and they're romping around, you see higher levels. Now, and to a large extent, you see that across the full spectrum of the particle sizes we're looking at. Some of that's just the embedded stuff, the stuff on the floor, even hard surfaces. You can kick up an amazing amount of stuff just by walking on a hard surface, let alone a carpet or let alone upholstery. But then there are other unique things like humidifiers. And in one case, a person was using using water that was not, what do you call it? You're supposed to use pure water,
like purified water.
You know what I mean?
Yeah. Yep.
And they didn't want to buy distilled water, so they used tap water, and their counts were 30,000 in a bedroom. And on the Dylos scale, 3,000 is very poor. Most houses, I think, are median levels, like 600 or 500. And as soon as they switched to distilled water, the level dropped way down. So it did not appear to be just a humidity factor. And that's, we're talking about complicated stuff, and we're simplifying it greatly. There are humidity factors. Obviously, when you're looking at outdoor stuff coming indoors, you're changing temperature and relative humidity. You've got interactions and all kinds of stuff going on, and we're definitely simplifying all that. But humidifiers can be a huge one. Sometimes just operating equipment, like in any hot surface, like using a toaster. In my case, I found that making coffee created really high spikes, and it was only because I hadn't really cleaned off the pad that gets super hot, for, months. And when I just really, really cleaned it off, it was a whole lot better. So lots of those kinds of things. Vacuuming can really kick up a lot of dust. So those are the things that people see. They see those spikes, and what's interesting is that using a monitor just for a week or two could easily let you know about the things that you're doing, and could in some cases give you feedback of things that, I can choose not to do this, and I can really lower my peaks. The other thing people do see is that when it's really bad outside, it can get really bad inside. That's sort of separate. But the main concern I have is that lots of times when people see those peaks, they sort of think, well, what am I going to do? Get rid of my kids? My air quality is great as long as I'm not here. Well, so in some cases, I think just seeing the peaks doesn't always empower you, and that you don't see clear solutions. And that's to really getting the levels significantly lower.
And let me, Cliff, I know you have a follow-up first.
Yeah, Linda, what about pets? Have you got any interesting information that you didn't expect, using the monitors with homes that have pets versus homes that don't?
We do ask folks a bunch of questions, and pets, candles, fragrance, things you do to put scents in the air, all kinds of things like that. All are questions we ask. We haven't analyzed that data, but we definitely, the thing is pets vary a whole lot, but pets definitely can be a source for the question of whether or not the pet is equal to a kid, a 3-year-old kid, or whether or not the pet is just because of all the stuff they shed. They often tend to shed fairly big stuff, but they kick out. There's two factors. One is their source of and their contribution, but then the other thing in terms of what they're putting off, but then the other thing is just their activity level. But definitely, and that's one of the things that portable air cleaners have been demonstrated. If people have pet allergies, that portable air cleaners definitely help reduce pet allergies.
The reason I mentioned it is Joe and I were at the Indoor Air Quality Association meeting, and I saw a presentation by Jeff May, and it was talking about dust mites, and I never really thought about my dog's bed being a source of dust mites, but it was. And I think people just talk about, humans and dust mites and being in bed with dust in our pillows and mattresses and all that other stuff. And, I think they just totally disregarded pets. So that's why I asked.
Yeah,
definitely. I got a text question that kind of ties into one that I had anyway. And Dale, thanks for sending these. It's with respect to carpet. Let's start with this. Did you find a difference in carpeted homes versus non-carpeted? Have you looked that closely?
No. What's been more surprising, and we do ask that question, but what's more and basically our data analysis has been primarily looking at the data we've gotten across the 70-plus folks who we have both indoor and outdoor data for, and looking at the variation in that data, and particularly looking at the indoor versus outdoor and the distribution of that data in terms of high to low and median, and some of the lag effects and correlations. So we're really looking forward to the issue of digging deeper, but you really need more homes for it to be more interesting to get into some of the house characteristic kinds of issues. What's been more surprising to most people, I think, is that hard surfaces, because you always hear, carpet's bad, hard surface is good, but if you've got hard surfaces, they really need to be cleaned regularly, or at least cleaned very, very thoroughly occasionally. That's what I found, was that if I just thoroughly cleaned like you would in a lead remediation level of getting the house that clean, I didn't have to then clean nearly that much, and it lasted a long time. But until I did that, I couldn't come close to controlling my particle counts.
And that leads.
Go ahead.
Go ahead. Well, that leads into another question that I had a text on, and then so we talked about carpet versus hard. What about replacement of carpet? The question is, how often should carpets be replaced to reduce particulate? Any thoughts on that?
Boy, every time you change owners, I sure wouldn't want the previous owner's crap to be in my air. So that would be an absolute minimum. But at the same time, a lot depends on the location, because you have all kinds of tracked-in stuff. So it really would be a hard call to make, depending on so many factors about the carpet. But I've just always avoided carpet, period. And lots of times it's very hard to clean carpet effectively, as you know. So those are level questions that we haven't really examined.
I got another quick text, and it's something that I'm interested in as well. You deal with HRV, ERV systems, and they may be helpful. And you mentioned in the earlier talk about having a distributed ventilation system. What about filtration on ventilation systems? Is there any recommendation for the level of MERV filter that you would recommend on HRV, ERV system?
There are recommendations on the effectiveness of different MERV ratings for addressing different micron sizes. You see that in EPA's website and LB&L's IAQ website. We are doing testing of different filters, and we're tending to use a MERV 13 4-inch pleated filter. What we primarily have found out in initial exploration is that 1-inch high MERV filters appear to work well at really knocking the numbers down if you use the air handler long enough. In most houses, we haven't seen a significant impact, but we haven't analyzed the data real closely. This is more from eyeballing the data. We haven't seen that houses that have 1-inch high MERV filters are significantly better than those that have no filters if they're only running the air handler on auto. But as soon as you change it from auto to on and run it significantly longer, we see a huge impact. But what we were curious about is what's the energy liability and what's going on with external static pressure. And then looking at that, we haven't found any case, and this is southwestern Pennsylvania housing stock and our typical duct systems, which are sheet metal duct systems. We've not found any house where a 1-inch high MERV filter should be used on a continual basis because of both the energy costs of doing so as well as the external static. We've seen cases where we could switch to a 4-inch and it's significantly better, but it's still not necessarily great. The highest we saw was 1,500 watts continuous. 1,500 watts is 36 kilowatt hours a day. That's, over $100 a month.
Wow.
We were talking about very high fan energy use. And that's not just because of the 1-inch filter. That's because of the way the duct system's set up. So even if you put a crappy filter in that's, $2 filter, you're still, if you ran the air handler continuously, you wouldn't get filtration, but you could get a high energy bill. So the issue is the energy use of air handlers. It's one thing if you're just using it in an auto mode and it only comes on for 2 hours a day, 3 hours, whatever. But if you were to use your air handler for your filtration system, you absolutely need to do stuff to drop the bottom out of that energy use. And we've done a couple. We've gotten one down to 110 watts. And that house, if they keep the windows closed, with that house they can have particle counts that are better than we thought possible with a MERV 11 or 13 filter, using the air handler continuously. But as soon as you open the windows, or if you don't address cooking emissions, you end up with high counts. But the emissions drop much, much faster if you have that continual air cleaning. So the key thing that, I know we're running close on time, the key thing we've found is that when you've got good outside air quality, and the neat thing about our region is we see within a 3 to 4 week period, sometimes where the air quality is pretty good outside, and on average it tends to be in the poor range, and there's periods when it's very poor. And we see a direct relationship to indoor counts that a person's not going to see if they're only looking at what are the peaks, where are the spikes.
Mm-hmm.
So what we're really curious about is what's the baseline? What's the amount that you're experiencing 24/7 when you're living in a house? When you're sleeping in your house and you're there for 10 hours, ideally, what are you breathing in your bedroom? And how can we really lower the exposure so based on the meters we've got, you're in the good to excellent zone, not the fair zone. And we've got a 10-to-1 difference between our best and our worst houses from the standpoint of indoor particles. And we typically see indoor being better than outside, but when outside is good, inside is good. I mean, except for those weird, those short spikes. And those spikes go way much faster when the outdoor is good because you get the dilution. So absolutely, the best solution for indoor air quality is to have good outdoor air quality. But every house needs, my takeaway is every house needs a way to clean the air, and whether that be something portable or something that's central, and it needs to be done in such a way that is affordable to use, which most air handlers, as they exist, are not. So that gets into the question I know you wanted to get to before we ended on the intersection of energy efficiency and.
Perfect. Why don't we go ahead and let you wrap it up on that? You were doing such a great job. I didn't want to interrupt.
Okay, so the key thing is, in energy efficiency, we've been very focused within building performance, home performance, whole house, weatherization assistance program, on combustion safety, on moisture sources, and not causing backdrafting and spillage, and not doing those kinds of things. But for the most part, we've not been looking at the issue of particles. They haven't been measured. They haven't been looked at. We haven't had diagnostic equipment to do that. With effective filtration, we could really give houses a vehicle that they could drastically improve, lower the particle counts from either indoor or outdoor sources, doesn't matter where it comes from, as long as they've got some way to filter the air. And the key is, we need, when we're installing new heating equipment or when we're modifying heating equipment, we need to have systems installed in such a way that you've got an efficient air handler, so the ideally ECM, which can move the air at a continuous rate at a far slower rate. The settings need to be right. Occupants need to be educated. There needs to be room and the airflow appropriate for a 4 or 5 inch filter. Ideally, you're not talking about the typical construction where you've got the filter slammed up against the furnace doing a U-turn, but instead you put the filter in the return drop. I'm talking about typical basement forced air systems.
Right.
But lots of energy efficiency programs are replacing systems. Lots of times we're putting in better, central AC systems. So we've got all these opportunities at that point to, without a huge increase in costs, to put in systems that provide for much better filtration, to make sure the settings are right on the thermostat, to give people information, and we absolutely need to somehow tie that into monitoring and education so that people replace the filters. Because if they don't replace the filters, you could have serious problems. Though with a 4-inch filter, it's going to move more air than a 1-inch clogged filter. But 1-inch filters just seem like a really bad deal based on my totally unbiased observations.
From what you're seeing to this point. Well, Linda, this has been a lot of fun, and we really didn't get a chance to dig down as deep as I would like, and I've got a list of questions remaining here. I'm hoping we can get you back, especially after you've had a chance to dig down a little deeper into some of this information. But what you've told us so far has been fascinating.
That's been a lot of fun. Thank you for the opportunity.
Well, thank you for joining us, Linda Wigington, and it was a lot of fun, and I hope we can do it again. Maybe like 6 months from now. You think you'll have a little more detail on some of the...
be analyzing the house characterization data. Can't wait to dig into that.
That would be great, and I'll look forward to talking to you offline as well. This is Radio Joe Hughes saying thank you to Linda Wigington. Fascinating show today, Cliff. I really enjoyed that. To my co-host, the Z-Man, Cliff Zlotnick. At the controls, John, you got to have faith. Most importantly, our growing group of loyal listeners. Thanks all. We'll see you 1 week from today when we're back with the next episode of IAQ Radio.
This has been another IAQ Radio production.